Hi guys, let's start the new exercise in this chapter circles. So let's look at certain more properties, a few more properties of circles, their chords and their arcs before we solve any questions. So let's look at the next theorem. It says there's only one and only one circle which passes through three given points which are not in a straight line. So I've already drawn a rough diagram for you to understand. Let's say point A, B, C are 3 points not in a straight line. So what is given is A, B, C are points not in a straight line. So I have already drawn that and I have already joined them as well. So what do we have to do? The first thing we do is one, join AB and BC. Next, I have already drawn the perpendicular bisector of AB and BC. So construct perpendicular bisector of AB and BC. Good. So let the perpendicular bisector be this be point, let's say B, and let this point be E. Good. Let the two perpendicular bisectors meet at point O. Okay, so let it meet at point O. Now let's join AO and BO. Okay, so next join AO and BO in triangle AOD and triangle BOD. What do we have? Number 5, angle ODA is equal to angle ODB is equal to 90 degree. Yes, this is by construction. Number 2, AD is equal to BD since OD is perpendicular bisector. And the next point would be OD is equal to OD, which is common side. What this means is therefore triangle ODA is congruent to triangle ODB. This is by side angle side test. What this means is OA is equal to OB. This is CPCTC. So we've got OA is equal to OB. This side and this side is equal. Similarly, we can prove that OB is equal to OC. So now join OC. So where I have join AO and BO and CO. Now in triangle OEB and triangle OEC, again we will be able to prove that these two triangles are congruent. So number 10, angle OEB is equal to angle OEC is equal to 90 degree. Next, BE is equal to CE. This is since OE is perpendicular bisector. Next one, OE is equal to OE, which is common. What this means is therefore triangle OBE is congruent to triangle OCE by SAS test. What we get from this is OB is equal to OC. This is CPCTC. So from 9 and 14, what we get is OA is equal to OB is equal to OC, which means O is the center of the circle and A, B, C are the equal radii, right? And since the perpendicular bisectors will meet only at one point, which means there can only be a one center. So OA is equal to OB is equal to OC is equal to radius of the circle with O as center. Last one line, and since perpendicular bisectors meet at only one point. Therefore, the only circle on which A, B, C will lie has center O. Perfect. So this is one of the theorems that we need for this next exercise, which is if you have 3 points or 3 given points, then there's only one circle which will pass through all 3 of them. Good. Let's look at the next one. The next one says equal arcs cut equal chords and equal chords cut equal arcs. The proof for this is not required. So what this means is if arc A, P, B, right, and arc C, Q, D are equal, which means if arc A, P, B is equal to arc C, Q, D, then what we will get is CD will be equal to AB. So equal arcs will cut equal chords, which means if arcs are equal, then the chords will be equal, which means chord AB would be equal to chord CD. Good. And the reverse of this would be if chords are equal, which means in this case, if EF is equal to GH, then the arcs which they are form a part of will also be equal, which means arc EKF would be equal to arc GLH. This is one of the most important theorem that we'll use in this exercise, which means equal arcs cut equal chords and equal chords cut equal arcs. Let's look at the next one. The next one we do is the theorem which says if 2 arcs or chords of the same circle subtend equal angle at the center, then they are equal. So 2 arcs subtend equal angle. So subtend would mean the angle that they make at the center. So in this case, the 2 arcs that we're talking about is arc APB and arc CQD. The angle that they subtend at the center, which is what I have marked here, which is angle COD and angle AOB. Then if these 2 arcs are subtending equal angles, then the arcs are also equal, or the chords are also equal. So the proof of this, let's look at this. So what is given is angle AOD is equal to angle COD. This is given. This is point 1. What we need to prove is AB is equal to CD, or arc APB is equal to arc CQD. This is what we need to prove. Let's see how we can do that. So let's look at these 2 triangles which are already formed. So in triangle AOB and triangle COD, do we have anything in common? Number 2 would be angle AOB is equal to angle COD. This is given. Next would be OA is equal to OC. Why? Radius of the same circle. So OA and OC is equal. Similarly, OB is equal to OD. Again, in fact, all of them are equal, which is radii of the same circle. What this means is these 2 triangles are congruent, which means therefore triangle AOB is congruent to triangle COD by side angle side test. What this gives me is AB is equal to CD. This is CP, CTC, and we just in the previous one said equal chords have equal arcs. So in this case, equal chord will have equal arcs. Good. So the proof of this is in your syllabus, which you should clearly know. And this also means that arc APB is equal to arc CQD. One and the same thing. Number 6 and number 7 are exactly the same. there's another proof which is the reverse of this. So let's look at that. So this is converse of the previous theorem that we just did. If two arcs of a circle are equal, which means what is given now is AB is equal to CD. This is what is given, and what do we have to prove? We need to prove that angle AOB is equal to angle COD. So what it's saying is two arcs, if two arcs are equal or two chords are equal, then they subtend equal angles. That's this what this theorem says, and this is a question in your book exercise 17D, question number 2. So let's see how we can prove this. In triangle AOB and triangle COD, do we have anything equal? Yes, we have AO is equal to CO. So AO is equal to CO. Next, BO is equal to DO. In fact, all these parts are equal because these are radius of the same circle. So this is radii of the same circle. And the third one, which would be AB is equal to CD. This is given, which means again these two triangles are congruent. Triangle AOB is congruent to triangle COD by SSS test. What this gives me is angle AOB is equal to angle COD. This is CPCTC. So that's what we needed to prove, that if two chords are equal, then they subtend equal angles at the center of the circle. Good. We'll use this a lot in this exercise. Let's look at the last one before we start solving some questions. So this one says so we've already done that. If arc APB is equal to arc CQD, so if arc APB is equal to arc CQD, then what we have, and if this is the center O, then what we have is angle AOB is equal to angle COD. We just did this. So then angle AOB is equal to angle COD. Next, if arc APB is 3 times arc CQD, which means they are in proportion but 3:1, then angle AOB would be 3 times angle COD. So whatever is the ratio of the length of the arc, the same would be the ratio of the angle that they subtend at the center. So whatever is the ratio of the length of the arcs, exactly the same is the ratio that they subtend at the center. Similarly, if arc APB upon arc CQD is 7:11, then the ratio of their angles will also be 7:11, which means angle AOB is to angle COD, not cos. Yeah, COD would be equal to 7:11. So whatever is the ratio of the arcs, that's the same ratio of the angle that they subtend at the center. And one last one, if there is a n-sided regular polygon. A quick reminder, regular polygon means a polygon which has regular polygon is a polygon which has all sides equal and all angles equal. So for example, an equilateral triangle, for example, a square, both of these are regular polygons because all sides are equal and all internal angles are also equal. So let's look at this property. If n-sided regular polygon is inscribed in a circle, we've talked about inscribed, which means the circle touches all the vertices of the polygon. Then the angle subtended by each side of the regular polygon at the center of the circle is given by the formula 360 degree upon n, which means in this case, if AB, AC and BC are equal, which means if my vertex angles are also equal and they are equal to 60 degree, then the angle that they subtend at the center is 360 upon n. N in this case is 3, which means this is 120 degree. So what this means is angle BOC is equal to 360 upon 3, which is 120 degree. Angle AOC is also 120 degree and angle AOB is also 120 degree. Good, so this is also something that we'll use a lot in this exercise. So let's try and solve our first question. When we apply them, I guess the questions will become clearer and these properties will become clearer. So question number 1. In the given figure, an equilateral triangle ABC is inscribed in a circle. Oh, that's exactly the thing that we did right now. Is inscribed in a circle with center O. Find angle BOC. So let's just write this down. Number 1, since triangle ABC is equilateral, therefore angle BOC is equal to 360 degree upon n. In this case, n is 3 because there is a three-sided regular polygon. So this is 120 degree. So we got the answer. Therefore, angle BOC is equal to 120 degree. I hope you realize, if you remember that one formula, this exercise is way too simple. Let's look at angle OBC. Angle OBC. So we are basically looking at this angle. So let's see how we can look at it. In triangle OBC, do I know any relation between any sides? Yes, I know OB is equal to OC. Why? Because this is radii of the same circle. So radii of same circle, which means triangle OBC is isosceles. Therefore, triangle OBC is isosceles. And what I get is angle OBC is equal to angle OCB. This is what I get, which means these two angles are equal. Now let them be equal to x. Now in triangle OBC, we just calculated angle O here, which is BOC, as 120 degree. So 120 degree plus x is equal to 180 degree. This is angle sum property, which means 2x is equal to 60 degree. Therefore, x is equal to 30 degree. They have not given x, so I would write the answer in the way they've asked, which is angle OBC is equal to 30 degree. Done. That finishes this video for me. I will see you with the next video. Thank you so much. Take care. Be safe. Bye-bye.